Good day. Welcome to the second lecture in Calculus 1. So, let's begin. Alright, so for the second lecture, we will discuss differentiation. So, let us first discuss the first principle in differentiation. So, we have the formula f prime of x equals the limit of f of x plus h minus f of x all over h as h approaches to 0. So f prime of h is what we call the derivative of the function at x. So for example, for the function y equal to x squared, find dy over dx from first principles. So dy over dx is also f prime of x. Alright, so in the given example, we are given y, so which is also equal to f of x, so that is x squared. So we need to find dy over dx, so which is also the same as f of x. So for our definition of f prime of x, we have the limit as h approaches to 0 of f of x plus h minus f of x all over h. So first we need to find f of x plus h. So we input x plus h to the function f, so we will get x plus h squared. Now expanding this, we get x squared plus 2xh plus h squared. So we all know that f of x is equal to x squared. So now we can substitute the given values to the definition of the derivative. So we have limit h approaches to 0 of x squared plus 2xh plus h squared minus x squared all over h. So we can cancel out squared. Now applying factoring on the numerator, we get h times 2x plus h all over h. So by that, we can cancel out h. So we left at 2x plus h. Now applying the theorem in limits, so the limit of the sum is equal to the sum of the limits. So we have limit 2x, so h approaches 0, plus limit h approaches 0. So the limit of 2x as h approaches 0 is simply 2x plus the limit of h as h approaches to 0 is equal to 0. So the answer would be 2x. Alright, so here are some properties of the derivative. So for the first one, the derivative of a constant function is 0. The second one, if n is a positive integer, then the derivative of x to the n with respect to x is equal to n times x to the n minus 1. For the third one, if r is any real number, then the derivative of x to the r is equal to r times x to the r minus 1. The fourth one, If f is differentiable at x and c is any real number, then cf is also differentiable at x, and the derivative of c times the function f of x is equal to c times the derivative of f of x. Then for the sum and difference rules, if f and g are differentiable at x, then so are f plus g and f minus g. And if we take the derivative of f plus g is equal to the derivative of f plus the derivative of g, and the derivative of f minus g is equal to the derivative of f minus the derivative of g. Alright, so we also have the product rule and the quotient rule. So if f and g are differentiable at x, then so is the product f times g. And the derivative of f of x times g of x is equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. And for the quotient rule, if f and g are both differentiable at x, and if g of x is not equal to 0, then f over g is differentiable at x, and the derivative of f of x divided by g of x is equal to g of x times the derivative of f of x minus f of x times the derivative of g of x divided by g of x squared. Right. So let's have this exercise. So compute the derivative of the given function f by a multiplying and then differentiating, and b using the product rule. So verify that a and b yield the same result. So here I'll just do number 1. So for numbers 2, 3, and 4, so maybe this is an exercise for you. So I'll just simply do number 1. Alright, so we have here the function f, which is this. So let us first multiply these two binomials. So we get 2x squared minus x plus 2x minus 1. And then after that, we apply differentiation. So we have 4x minus 1 plus 2 minus 0. So we get 4x plus 1. Now for another method, we will use the product rule. So f prime of x would be, so do not forget the rule for differentiation of product. So we first put x plus 1 and then multiply by the derivative of the second term, so which is 2, plus we have the second term times the derivative of the first term, so we have 1. So we will get 2x plus 2 plus 2x minus 1. And then by combining like terms, we get 4x plus 1. So we have the same answer as this. Alright, so let's have higher derivatives. So the derivative f prime of a function f is itself a function, and hence may have a derivative of its own. If f prime is differentiable, then its derivative is denoted by f double prime, and is called the second derivative of f. As long as we have differentiability, we can continue the process of differentiating to obtain third, fourth, fifth, and even higher derivatives of f. These successive derivatives are denoted by these symbols. So f prime meaning the first derivative, f double prime is the second derivative. So we get the second derivative by differentiating the first derivative. For the third derivative, we differentiate the second derivative. For the fourth derivative, we differentiate the third derivative. And for the fifth derivative, we differentiate the fourth derivative. So if y is equal to f of x, then successive derivatives can also be denoted by these symbols. Alright, so let's have this example. So let y be equal to ex to the fourth plus bx squared plus c, where a, b, and c be elements of the set of real numbers. So we need to find y triple prime, meaning the third derivative. So let's have the solution. So we first get y prime. So we have 4ax cubed plus 2bx plus 0, which is equal to 4ax cubed plus 2bx. Now, getting y double prime, we have 12ax squared plus 2b, so only 2b. And finally, for the third derivative, so we get 24ax. So this is your final answer.